Hi, welcome back. Today we're going to be talking about angles of triangles. Make sure you have something to write with, something to write on, so that you can take some notes and make the most of this video. If you haven't already, click the subscribe button. I know you want to. And if at any point you find something here that's useful, that's helpful for you, go ahead and hit the like button as well. That lets me know that this video was useful for you in some way. And if at any point you do have a question, put it in the comments. I'll respond to your question, and I can clarify anything that you might have a question with. Let's get started. So, excuse me. In this video, we're going to talk about two main theorems: the triangle angle sum theorem and the exterior angle sum theorem. These are the two topics we're going to be talking about. I'll explain the theorems. I'll go over some examples, and then at the very end of this video, I'll do two examples of both of these together so that I can tell you how to identify the difference between which theorem to use under which circumstances and things like that. The first thing I want to talk about is the interior angle sum theorem. Okay, for this one you can do the experiment with me. Feel free to grab some scissors, cut a triangle as straight as possible, or do it with a straight edge. Use a ruler to make straight lines and cut out a triangle. Then what you're going to want to do is you're going to want to tear the corners off. Once your triangle is neatly cut out, tear the corners off. And I'm going to show you what I mean by that here. I'm going to start with C. And I'm going to neatly tear the corners off. This is angle C. I'm going to do that same thing with angle A and B. Now, if you're doing it yourself, you're going to have three big pieces, right? One for corner C, one for corner B, and one for corner A. For corner B, I have this piece. And then for corner C, the last piece. Now, the purpose of this is I want to show you that if you take the angles of a triangle and you put them together and you organize them in a way, I'm going to rotate this stuff. Excuse me. You rotate them in a way that you can put them next to each other. You line them up. Okay? So here we have a vertex. I'm going to change this one over here a little bit. Put it side by side as much as I can. Ooh. Sorry, things are going crazy here. There it is. Now, you should be able to put these corners closer to each other so that they can touch each other right next to each other. Right? I'm not able to do that because I cropped it through here and I'm limited a little bit. I'm struggling a little bit with this. There it is. Now, when you put them together and you have the sides touching each other, you should see that together these three angles form a line, a perfectly straight line here at the bottom. Okay, and what that should tell you is that the angles combined, if they form a line, right? If the angles combined form a line, then this angle should measure 180 degrees, right? So, and that's actually what we call triangle angle sum theorem. Officially, what it means is that the measure of the three angles combined should equal 180 degrees every single time. No matter what triangle you constructed. In this picture, it looks like we have an obtuse triangle. You can do an equilateral triangle, obtuse triangle, a right triangle. No matter what type of triangle you construct, if you cut the corners together and you put them side by side, you will see that it'll always form a straight line. These three angles will always add up to 180 degrees. And what we're going to do is we're going to use this theorem to solve for some missing angles. So let's give a few a try. Find the measure of each numbered angle. Here on the picture on the left, we have a few pictures, a few angles. We have angle 1 that's missing. Angle G is 152 degrees. Angle A is 20 degrees. Now, I know that these three angles combined should add up to 180. So if you want to set up an equation, you can. You can say angle 1 plus 20 plus 152 should equal 180. And then you can just solve for angle 1. You can combine like terms. Angle 1 plus 172 equals 180. You can call this angle 1, you can call it x, you can call it however you like, but we're looking for this missing angle. We subtract for 172 on both sides, and you see that the measure of angle 1 equals 8 degrees. Let me just write this neater. Okay, so all you do is you combine the angles that you have, subtract it from 180, and that gives you the missing angle. Let's look at this next picture. For this one, we're missing two angles. We're missing angle 1 and we're missing angle 2. So our goal is to find the measure of those two angles. Let's start with the measure of angle 2. Now this here, we have a right triangle, right? Here at W, we have 90 degrees. We have 30 degrees at S, and now we're missing the value of 2. So I'm going to do this in red. I have angle 2 plus 90 degrees plus the 30 should equal to 180. Right? So if I combine like terms, I have angle 2 plus 120 equals 180. And then I can solve for angle 2 by subtracting 120 on both sides. And I know that angle 2 measures, the measure of angle 2 equals 60 degrees. So this piece right here is 60 degrees. Now our goal is to find the measure of angle 1, and I'll do that in a different color. Let's do that in green. Now for this triangle, you can use the measure of angle T, angle 1, plus this angle here to set it equal to 180. Or you can use the fact that this angle, you can use the fact that angle R is composed of two things. You can use a full triangle if you want and set that equal to 180. You already know that the smaller piece is 60 degrees, so 60 plus something plus 60 plus 30 should equal 180, or you can treat them separately, right? As I said, you can look at just this triangle by itself. That would also work to find the measure of angle 1. I'm going to find the angle of angle 1 with it being separate, just to keep the number simple. Okay, so I have measure of angle 1 plus 60 degrees plus 90 degrees equals 180. Now I know this is at W is 90 degrees as well, because right next to the W, on the other side of W, we have a right angle, and together they form a linear pair. So 90 plus 90 should give you 180. All right, so we continue to solve. We have angle 1 plus 150 equals 180. We subtract 150 on both sides, and we're left with the measure of angle 1 equals 30 degrees. Now, if you think about it, this corner at R has a right angle. 90 degrees. So since angle 2 was 60, angle 1 is 30. Together, 60 plus 30 should equal 90. It's another way to verify that you've done this correct. Let's talk about the exterior angle sum theorem. Now, the exterior angle sum theorem now includes an angle on the outside. We have angles inside, which is what the previous one was called, interior angle sum. They're angles on the inside of the triangle. Now we're talking about the exterior angle sum theorem. Exterior means outside. So we're going to look at now the fact, how is the outside angle being affected? So we have an angle on the outside over here. We'll call that angle ACB. ACD, sorry. That's this piece. How do we find the measure of that angle? Is actually, we're going to add the two angles on the inside, angle B and angle A. If you add those two, the angle opposite of those two on the outside is going to be the result of adding the angle A and angle B. So here's the official formula. If I add these two angles, the opposite angle on the outside should be the result. And I get the measure of angle A plus the measure of angle B should equal this exterior angle, measure of angle ACD. It's got to be the angle on the opposite of these two together. So these two angles, you add them up, the opposite angle on the outside will give you the result. Let's try a few examples. So here we have 50 and 65. If I add these two on the exact opposite side, on the outside, this exterior angle should be the result of these two added together. So my formula looks like this. 50 degrees plus 65 degrees should equal the measure of angle 1, which is on the outside. 50 plus 65 is 115 degrees. And that equals measure of angle 1. Now, let's say that you don't remember the exterior angle sum theorem, and instead you want to find this angle first. Well, you know that these three angles combined should add up to 180 degrees. Right? So if you want to use the previous rule, the triangle interior angle sum theorem, you can add 50 plus 65 to find this missing angle on the inside. 50 plus 65 is 115. You subtract that from 180. What do we get? Let me see. We get 65 degrees. So then this angle down here is 65. Now, to find angle 1, I do notice that together they form a linear pair, which means they add up to 180. So if this side is 65, we do 180 minus 65, and that's how we still get 115 degrees for this exterior angle. Now, obviously that's more work. You have to add them, subtract it from 180, and then subtract it from 180 again because they form a linear pair. But if you're having trouble with the exterior angle sum theorem, the interior angle sum theorem also works. Let's look at this other example on the right. So here we have two missing angles. I'm going to start by finding angle 1. So 35 plus 25. Combined, I should get angle 1 on the outside. So let's start with that. 25 degrees plus 35 degrees should equal the angle on the exterior, angle 1. If I add those, I get 60 degrees equals the measure of angle 1. Now, if this piece is 60 degrees, and together 1 and 2 form a linear pair, we know that linear pairs are supplementary, right? We know that measure of angle 1 plus measure of angle 2 should always equal 180 because they form a straight line. So if measure of angle 1 is 60, we can find the measure of angle 2 by solving for our missing value. Subtract 60 on both sides. Measure of angle 2 equals 120 degrees. And that's how we go about finding both measures. Now let's put it all together. Let's look at some examples, okay? When you're looking at a problem and you're looking at finding a missing angle, which theorem do you go by? Both theorems will work. It depends on what information is being presented. So as I analyze this triangle, I have 3 missing angles, angle 1, angle 2, and angle 3. I'm not going to start with this triangle over here because in order to find a missing angle, I need to know 2 of the angles. I can't add 2 unknowns with 50 and say that, well, the whole thing is 180 because I don't know 2 things. Over here, I do know 2 angles, so I can find the missing angle, right? If I add these 2 and subtract it from 180, I get the missing angle, angle 1. So I'm going to start with that triangle here on the left. Triangle MPQ. And I'm going to first find angle 1. So we got 58 plus 66 plus angle 1 should equal 180. If I combine like terms, we got 58 plus 66 is 124 equals 180. To solve for angle 1, I subtract 124 on both sides. The measure of angle 1 equals 180 minus 124, and that gives us 56 degrees. Now I need to find angle 2 and angle 3. How do we go about that? Well, if this angle is 56 degrees, and angle 2 is a vertical angle, notice how they're exact opposite. These 2 lines are intersecting. That means that angle 2 and angle 1 are vertical. Because angle 1 and angle 2 are vertical, that means that they're also congruent. So, measure of angle 1 should equal to measure of angle 2 because they're vertical angles. Therefore, measure of angle 2 is also equal to 56 degrees. Now that I know this is 56 degrees, I can now find the missing angle, angle 3, by now focusing on the second triangle. The second triangle, NOQ, right, should also add up to 180. So, I have angle 3 plus the 56 degrees from angle 2 plus the 50 of angle O should equal 180. Combine like terms, angle 3 plus 116 equals 180. Solving for angle 3, we subtract 116 on both sides. Measure of angle 3, or the measure of your heart, will equal 180 minus 116, and that gives us 64 degrees. And there it is. We find angle 2, angle 3, and angle 1, and we got all of our missing angles. And here, I use the exterior angle sum theorem to do it. Sorry, the interior angle sum theorem, because we added angles on the inside to equal 180. Yeah. For this next example, let me see. Did I do the exact same example? Yeah, well, scratch that. We'll do a different example in class as a warm-up. You can go ahead and give this one a try, and if you want, you can do this one using the exterior angle sum theorem. Right? If you wanted to use the exterior angle sum theorem, we could add up these 2 angles. Let's see, angle M and angle P. If you add them together, it should give you the angle here on the outside. And then you can use that to find as a linear pair. You can use it to find angle 2. Once you know angle 2 from a linear pair, you can add these up and set them equal to 180. Anyway, here's another example of how you can use it, how you can solve for a problem looking at either the interior angle sum theorem, where they add up to 180, or the exterior angle sum theorem. Okay? Beginning of triangles, beginning of this unit. By the end of the year, we're going to see so many different examples of how to solve for problems using triangles that you're going to be seeing it everywhere. I hope you guys have a great day. Please let me know if this helped. Like and subscribe if you haven't already. And as always, we'll calculate later.